Hey guys, this is CHEMPLIFIED and today we will talk about methods of preparation of alkanes. So there are various methods which also include name reaction, but we will talk about name reaction in the upcoming videos. So let's start. The first method of preparation of alkane is hydrogenation of alkanes or alkynes. Hydrogenation of alkenes or alkynes. The statement will be alkenes or alkynes react with hydrogen in presence of nickel catalyst at 200 to 300 degrees Celsius to form alkanes. Now since we are using nickel as catalyst, nickel is a metal, so we can simply state that it is adsorption based. The hydrogen will be adsorbed on the surface and then the alkene and alkyne double bond, triple bond will react with that hydrogen to give alkene. The reaction is alkene or alkyne when treated with hydrogen in presence of nickel and heat, alkane is obtained. Similar goes for the alkyne. Now in this place nickel catalyst is used, we can also use platinum. Sometimes platinum can also be used for the production of alkanes. So this is a simple reaction. It can be treated like this. You can suppose this is nickel surface, hydrogen atom come close to nickel surface and get attached to it in this way, H and H and H. Now this bond will break, right? After that alkene or alkyne double bond or triple bond will come close. This hydrogen will attach to this carbon, this hydrogen will attach to this carbon, releasing the bond electrons and giving single bond, carbon carbon single bond as in alkane. That's how you get the product from alkene and alkyne, right? This was the first method known as hydrogenation of alkene or alkyne in presence of nickel catalyst. Let's go for the second method, reduction of alkyl halide. Alkyl halide undergo reduction with nascent hydrogen to form alkanes. What is nascent hydrogen? Single hydrogen atom. This is hydrogen molecule. This is single hydrogen atom known as nascent hydrogen to form alkanes, right? The reaction will be like this. Alkyl halide when treated with nascent hydrogen gave alkene. Now this is very simple reaction, right? There are two nascent hydrogens One will attack the halogen and other will go for the formation of alkene. That's why halogen and hydrogen are together in the product. The reaction is ethyl bromide. Ethyl bromide when treated with hydrogen will give ethane and hydrogen bromide. That's how the reaction will takes place. This is general reaction. This is example for this. Another method, before we go for the next method, there is a note. The hydrogen, the nascent hydrogen that we are using, the hydrogen for the reduction of alkyl halide may be obtained by using any of the following reducing agent. These reducing agent, zinc plus HCl, zinc plus CH3COH and lithium aluminum hydride, will provide the nascent hydrogen required for the reduction of alkyl halide. So you can also take note of that these provides the nascent hydrogen, right? Now let's move to the next. Decarboxylation of carboxylic acid. Now as the name suggests, decarboxylation. So decarboxylation simply means removal of either carbon dioxide or carbonate group, right? When sodium salt of carboxylic acids, what is sodium salt of carboxylic acid? CH3COONA, positive, negative. This is sodium salt of carboxylic acid. The alkane group can be either taking CH3, you can give RCOONA. So this is sodium salt of carboxylic acid. When sodium salt of carboxylic acid is heated strongly with soda lime is NaOH plus CaO, calcium oxide. A molecule of carbon dioxide split as carbonate and an alkane is formed. Right? Let's take a look at the reaction. This is sodium salt of carboxylic acid. When treated with NaOH, CaO is also present, gives alkane. Now, how we are getting the alkane? This whole group combined with this group. Let me remove it. And the hydrogen will attack the alkyl part to give alkane. And in the product, you will also get Na2CO3. Right? That's how the reaction takes place. Now, the example is sodium acetate plus sodium hydroxide will give you methane. Now, the thing to note about this particular reaction is, in the reactant the number of carbon is 2, right? But in the product the number of carbon in alkane group is 1. So the number of carbons in the product will be 1 carbon less than the reactant. You can note it down. Alkane produced contain 1 carbon less than the original acid. The original acid in this particular case contains 2 carbon, but the alkane here contains only 1 carbon. So remember this thing about this particular reaction. Now the fourth method of preparation is hydrolysis of Grignard reagent. Now what is Grignard reagent? In general terms it is written as RMgX, alkyl magnesium halide. Alkyl magnesium halides. These are obtained by treating alkyl halide with magnesium in anhydrous ether. What is the meaning of anhydrous? Anhydrous means any compound that contains no water, or you can say any crystalline compound that do not contain any water molecule in it. So when alkyl halide is treated with magnesium in anhydrous ether, we get Grignard reagent, and these on treatment with water, when Grignard reagent is treated with water H2O, it gives alkanes. Let's look at the reactions. This is alkyl halide. When treated with magnesium, this is our Grignard reagent. Now after getting the Grignard reagent, here R is the alkyl group, right? This Grignard reagent when treated with water will give alkene. Now this group will take out the OH group and the hydrogen will get attached itself to alkyl group, right? That's how it works. So this is the reaction of Grignard reagent with water to obtain alkane. So these were the 4 methods of preparation of alkane. The other methods of preparation are wood synthesis, core house synthesis and coal base synthesis. Now if you think about it, all these are named reaction, right? So we will discuss these named reaction one by one in the upcoming videos. So this will be it for today's video. These were the 4 methods. Thank you very much.